Hi, my name is Paolo Masci. I'm a user interface expert from Queen Mary, University of London. In this talk, I will demonstrate issues we identified in medical devices from different manufacturers. The demonstration is given using infusion pumps as example. Infusion pumps are devices used in hospitals to deliver drugs and nutrients at controlled rates and volumes. The values of rate and volume are usually entered by nurses using button and keys on the device user interface. I will now demonstrate design errors that can potentially lead to situations where wrong rates or volumes may accidentally be entered in the device. The first user interface we consider has navigation keys, that is, 4 arrow keys and a display. The manual explains that to enter rate or volume values in this device, you just need to use the arrow keys. That is, you can use the up key to increment a digit and the down key to decrement a digit. And then you can use the left and right buttons to select a different digit. So, for instance, if you want to enter 1.1, you need to go up one time, right, and then up. In this device, the digits are not independent. That is, if you go to 9 and then you go up, you go to 10, and so on. And if you go down, from 10 you go to 9, and so on. Now, let's try to enter a high value. So let's go to the leftmost position, and we start going up. From this value, if I press the up button, what do you expect to see? I guess you expect to see 100,000. Well, the device returns this value instead, without any warning or notification. The reason for this is that the device does not support any value which is greater than 5 nines. So, in this case, the device is showing the maximum value. Now, from this value, if I press the down button, what do you expect to see? I guess you expect to see 8 and 4 nines. This is not the case. The device reacts this way. So you see, what's happening is that the device is recalling the previous value. So every time you overshoot the maximum value, you can recall the previous value. Well, this is not always the case, because if you see this display here and you go down, you actually modify this digit this time. So let's try to do this again. We go up, overshoot the maximum value. We can recall the previous value in this case, but we cannot recall the previous value in this case. The reason is that I've pressed the left and right buttons, and those buttons are overloaded with the clear memory button. So when I press them, I just clear the memory and I cannot recall the previous value anymore. This creates situations where you see this number and you don't know what is the effect of pressing the buttons, because you may recall the previous value or you may simply edit a single digit. This device has constraints in the way numbers can be entered. So usually you have 2 fractional digits precision. So if you want to enter 10.01, you can do that. But if you want to enter 100.01, you cannot. You see, when you are above 100, you just have 1 fractional digit. And if you want to enter 1000.1, you cannot. So for all values above 1000, you cannot have any fractional digit. Let's consider a device from a different manufacturer. This device has a similar layout with navigation keys. However, the behavior is totally different. In this case, for instance, you have independent digits. That is, from 9, if you go up, you don't go to 10, you roll over to 0. This applies to all digits. So in this device, if you try to overshoot the maximum value, you obtain this behavior. The problem with this device is that it allows the cursor to jump from the rightmost position to the leftmost position with a single button click. So if I press right here, I just jump there. Similarly for the left button. And you can see the problem here. So if you are at 32 and you want to enter 32.01, so you go twice right. If you accidentally hit this key one more time, you just jump there and you end up entering 132. Let's now consider another variant of the navigation keys. So in this device, you have independent up and down keys. So each one of these keys modifies a single digit. Well, at least this is the impression that you get, because if you start operating the device, you will notice that this is not the case. You see, a problem with this pump is that the display is able to support 3 integer digits and 1 fractional digit, but the pump actually supports values up to 1200. So if you try to enter numbers above 999, what you get is that the display shifts the numbers. So you see, from 9 to 4, you go to 10 to 4, and you have this digit, which is an integer digit, which is displayed smaller than the other integer digits. So from the distance, you will likely read 102.4. Let's now consider a different type of device. In this device, if you want to enter 2.01, you need to press 2.01. So the interaction seems to be easier than the previous devices. However, there are issues here as well. Let's try, for instance, to enter 20.01. So 20.01. You see, the device is ignoring key presses. In this case, the reason is that for numbers above 10, numbers can have just 1 fractional digit and not 2. That's why I'm allowed to enter 2.01 but not 20.01. There is a similar rule for numbers above 100. So all numbers above 100 cannot have fractional digits. So in this device, I'm not allowed to enter 200.3, for instance, 200.3. You see, the device is rejecting the value. But you see, the feedback is too high, which is kind of strange in this device because the maximum value is 1200s. So 200.3 should be allowed. And in fact, if I try to enter 201, I'm allowed to do that. 202, I can do that as well. But 200.3, I get this feedback. The problem is that the device is ignoring one key press. So look carefully. 200 point. You see, there isn't any decimal point here. The device is ignoring the decimal point. So that's why as soon as I press 1 here, I get too high as a message, because I'm actually entering 2001 instead of 201. There are situations where I don't get this kind of feedback, but the number is accepted without any warning. So we said the maximum value is 1200. So if I try to enter 100.1, I get 1001 instead of 101. And this is a problem because we have made some eye tracking experiments, and when you enter numbers with this layout, you usually look at this part of the device. So you look at buttons and not at the display. So you will totally miss that you have a wrong number here. You will simply confirm and you start the infusion. Another problem with this device is that it accepts illegal key sequences. So, for instance, if you enter 0.9, which is an illegal number, the device does not complain and registers 0.99. And we don't know if the user actually meant this number or simply made a key slip error, so accidentally press one more time the decimal point. So maybe the user meant 9.9. So here again the device is not notifying the user, it's just accepting the value, and when you start the infusion you don't notice that you have a wrong value, because again you look at this part of the device and not at the screen. Let's consider another device from a different manufacturer. It has the same problems. So in this device as well, if you select the rate and you try to enter 100.1, 100.1, you see the device is complaining because it registers 1001 instead of 101. In this case, the value is rejected because the maximum rate is 3 nines instead of 4 nines. But if you get a software update where the maximum rate is changed and goes to 4 nines, then this value is going to be accepted by the device, and you have exactly the same problem of the previous one. Here it's interesting to notice also that the display is telling a lie, so it's displaying 100 while the actual value is 1001, and indeed the user cannot confirm this value. The only option here given by the device is to clear the display and re-enter the value. Let's go to a different model. This device has different problems. In this case, you have two buttons, rate and VTBI, to select the parameter you want to enter. So let's say we want to enter rate. So we click rate and we enter value. Let's say we enter 52, and we confirm. Let's say we notice that, well, we didn't want to enter 52 but 5.2, so we want to edit the value. So we select rate we enter 5.2. At this point we need to enter VTBI, so we select VTBI, and you see the device has discarded the entered value without any warning. The problem here is that the device requires the user to press OK, but there is nothing on the screen that suggests that you need to press OK. So let's repeat this. We select rate, we enter 5.2, and we select VTBI, and the value is discarded. Instead, if we select rate and we enter 5.2, we confirm and select VTBI, everything is fine. In a different device, you have a different behavior. If we consider the previous device, so here again you have rate and VTBI. If you select rate and you enter 5.2 and you confirm, and then you select again rate and you enter 5.2 and you change the selection and go to VTBI, you see the value is automatically confirmed. So this has the opposite behavior. Let's consider this other device. This device accepts illegal values. So, for instance, if you enter 0.98 without the decimal point and you press enter, the device does not complain and it registers 98. So you see the problem here, because you may have made just a key slip error, so you missed the decimal point and the device does not say anything at all, and you have a number which is 100 times larger than the intended one. Now let's go back to the slides. So what we are seeing is that devices that look simple and are sold as simple devices to use, they are actually very complex. So we have seen that this device, for instance, has memory. In our labs we have reverse engineered this device, and it took us 3 pages to explain what is the behavior of those 4 buttons. So we have seen that devices that look similar may have completely different behavior. We have seen that some devices ignore the decimal point. So in this device, for instance, if you enter 100.1, you get 1001 without any warning. You have similar problems in similar devices from different manufacturers. We have seen that some devices ignore values, and this is exactly the same problem that we have seen in all ventilators we analyzed. Some devices accept ill-formed values, so we are seeing this one that you can enter something like 0.89 and the number is registered as 89 without any warning. Similar problems are in patient monitors. So look here. In this case there is a number which has a decimal point. I'll give you some help. This. So you see here, this software accepts values like 0.9 without the leading 0, and you can easily read this number as 9 instead of 0.9. You have a similar problem here. So 0.89, there is no decimal point at all, so this is 89. There are issues with timeouts. So if you enter a value and you wait some time, what happens is that in many devices the value is just reverted to the previous value. We have seen this in many ventilators and patient monitors. Then there are issues also with the angle from which you see the screen. For instance, what number is that? I think you agree with me that this looks as a 9. But let's look at this from a different angle. What number is that? I think you agree with me that this is a 4. Let's try a different angle. Oh, you realize that this is not a number, this is a letter. So in this case, I guess you agree that this is an H. It was A. You can reproduce this kind of errors in all devices with 7 segments displays. Unfortunately, there are many devices with this kind of displays, from infusion pumps to phaco's to patient monitors to infant warmers. Many devices have also an inconsistent use of soft buttons. So a soft button is a programmable button. Usually you have a hard button and a label which is displayed on the screen. In this case, for instance, you have 4 soft buttons, but the soft buttons are just here on the left, not on the right. So if you click this soft button, you don't do anything at all. You need to press this one to select the infusion modes. But the behavior of the device is different in different modes. So if you change mode, you have here that these are not soft buttons at all. Here, this is text, and it's accidentally aligned to the soft buttons. So what you do here is usually read the text, so you cannot proceed because the parameters are incorrect. So you need to remove the syringe and reprogram, and you press reprogram. But, well, there is an issue here because the pump does not have any reprogram button at all. And then you realize that there is something here that says, oh, this is reprogram. So there is a soft button called reprogram, which is hidden here. And of course, when you read the message and you focus your attention here, you may not notice that the button is here. In this other case, you have these buttons on the left that work and these on the right that do not work. So to edit a value, you need to select the label rather than the value, which is kind of strange. Finally, here you have 3 labels. None of this works. So you press these buttons and nothing happens. So if you want to select a different channel, what you need to do in this pump is to press this button. Here, if you want to adjust the rate, you can try to click any of these buttons. They don't work. Even if this one seems to be enabled, because there is this one that is disabled, so you see the difference. This is not working. So you can click all buttons and they don't work. What you discover is that to edit the maximum rate, you actually need to connect this pump to a computer and modify the maximum rate from the computer. And nothing on the screen suggests that this is the way to proceed. Then we have seen that sometimes you get wrong feedback. So in this case, you see the pump is asking to select the maximum limit options, but it's actually asking to do something else because you need to answer yes or no. And probably the question was in the previous screen, which is not here. In this case, you have a number 1 displayed, but the pump actually registered 0. And finally, this device is completely non-informative. You can see you have yes and no, but you don't have what is the question. Additional papers and reports about user interface issues can be found on www.kaimet.ac.uk.